Hello students, this is the Interim Assessment 3 review. It's part 2 of a 2-part video series. I answered the first, I think 24 questions on the first video. Now we're going to go on to the next section. Oh, it looks like I answered 25 questions in the previous video because this one's number 26. Pause the video, see if you can get them right. Alright, looking at 26, it asks us to use the properties of rigid motions to explain why these two triangles are congruent to each other. Since they're congruent, since it was a rotation that happened, a rotation preserves all sorts of things, like length and shape. So since it preserves those two things, these two triangles are congruent to each other. You should mention in your response that this is a rotation, not a reflection. You can tell it's not a reflection because of the way that the sides are oriented. This one is pointing straight up, and it's the one that's 3 units. So now it's pointed straight down, and it's 3 units. If it were reflected, it would be pointed to the left here. All right, question 27, it tells us that a scalene triangle is formed between these two lines, and it says it's trying to prove that these two lines are parallel to each other. Well, if two lines are parallel to each other, then you should probably know that the alternate interior angles are going to be congruent, which means all 4 of these statements have angles, but only one of them has alternate interior angles. That's this angle here and this angle here, for example, CFG and FCB respectively. For question number 28, it gives us 2 triangles, and it notifies us that the line that's drawn inside this triangle here is parallel to that bottom side, which means that these 2 triangles are similar. This line is just segmenting that triangle into a smaller triangle, an inside triangle, and a larger triangle, which is the outside triangle. Since they're similar, we can use proportions to find missing sides. 9 divided by 14 is equal to 9.2 divided by AC. Crisscross applesauce, and we should get 14.31, aka to the nearest 10th, 14.3. For question 29, it talks about medians. Medians are lines that connect vertex to midpoint of the opposite side. And a centroid is the point where all the medians intersect, and it splits the medians into 2-to-1 ratio. So this part is going to be 2, and this part is going to be 1. The centroid rule says that 2 times the base part is equal to the vertex part, because you can see the base part is half as big as the vertex part. We set up the equation and solve. It's not a big deal because you know algebra, because you're super smart. Moving on to the next page, question 30. Please pause the video, try these questions out, and then see if you got them right. All right, for number 30, it brings to mind all the different lines that you can draw inside triangles, and I have a helpful guide here to help you figure out which ones the lines are. Perpendicular bisector is one of those lines. A median is another one. Angled bisectors are a third, and the fourth type is an altitude. You can tell that CD intersects the vertex, that's right here, and it also intersects the midpoint of the opposite side, that's here. This is, of course, the construction of a perpendicular bisector, which means we found that D is a midpoint, which means C to D goes from vertex to midpoint. If it goes from vertex to midpoint, it must be a median to side AB. Now be careful, because this construction right here is the construction of a perpendicular bisector, but the question didn't say, what's the dotted line? The question says, what is CD? CD is not the dotted line, CD is this bad boy. That's a median. All right, question number 31. It gives us a whole bunch of information, and then it again says DE is parallel to AB. That's 2 parallel lines, this line and that line. That means that the 2 triangles are similar. If the 2 triangles are similar, we can make a proportion. Crisscross applesauce means that we get to x is equal to 6. For question number 32, we're given some information about this triangle. We have an exterior angle here. So we're able to do 2 different things. We can use the exterior angle theorem, or we can use supplementary angles and then the triangle sum theorem, which is probably my favorite way of doing it. The statement that is true, well, according to the triangle inequality, we know that this is the largest angle, which means this is the largest side. Smallest angle means that this is the smallest side, AC, and then angle C here is the medium angle, which means AB is the medium side. So we set that up and try to figure out which one of these statements is true, and this one is true because AC, the smallest side, is smaller than a different side. That's the only one that could possibly be true, because this one talks about AC being bigger than something, and AC is the shortest side. You can go through the questions, the possible answers yourself. Question 33. It tells us that there's a rotation of 180 and a dilation. A rotation goes first, then the dilation. The dilation makes the sides proportional. Which relationship must always be true? Well, we know that if the angles are going to be equal, that's what happens in a dilation, then the ratio of the angles should be equal to 1. Like if the measure of angle A divided by the measure of angle D, those two angles are the same, so that should be 1, not 1 over 2. Same thing, this should be 1, not 2 over 1. But I can see that angles B and E are corresponding. That's 1 dot here and 1 dot here. C and F are also corresponding, 2 dots here, 2 dots here. So since they're corresponding, which means same place, different object, they are congruent. Which statement is not always true with the congruent statement? Well, the congruent statement tells you the order in which the letters should be. So for example, A, B, C, X, Y, Z, it says that A should be in the same place as X in your answer. So just taking a look at these ones, angle C, which is here, CAB, so C to A to B, and then ZXY, starting at Z, which is here, to X to Y. It's going in the same exact pattern. Since it's going in the same exact pattern, this is true. We're looking for the one that is not always true. The one that is not always true is letter B because it's not in the right order. CA, which is going from the back to the front, is not the same as XY because that's not going from the back to the front. Nice try. Moving on to the next page, we're looking at questions 35 through 40, and a lot of these questions are big questions. They have like multiple different things that you have to do, like diagrams that you have to draw out, so I separated some of them into different pages. You might want to take the time to take out a piece of loose leaf paper or computer paper, try them on a larger piece of paper, and then see if you get them right. All right, here's question 35. As you can see, I put it on a separate piece of paper because there's a lot going on here. There's just two different triangles, and it's asking from the distance from A to D. Well, I'm going to try to figure out the distance between A and C first, because that's part of a big triangle. Then I'm going to find the distance between D and C. That's the part of a little triangle. And then I'm going to subtract them out. Fairly straightforward because both of them use tan, which is the tangent function, and both of them are solved in the same exact way. You find the value of tangent, and then you cross multiply to get the measures of AC and DC respectively. The thing that I wrote over here is a helpful guide. You should get in the habit of doing this. I know that side AC, which is this big old side here, is equal to AD, which is from here to here, plus DC, which is from here to here. This is segment addition at its finest. I know AC because I solved for it here. It goes there. I know DC is 435.9958. I put that in here. Then I just solve for AD. It asks us to round to the nearest foot. Every time I do sine, cosine, tangent, I'm rounding to 4 decimal places, but at the end of the problem, I'm rounding to the nearest foot, which means the nearest whole number, 353. Boom. Question 36 is another multiple triangles problem, but it doesn't actually give us a diagram. This is probably the most challenging problem on the packet because it doesn't give you a diagram and it's fairly complex. Here's the flagpole. Boom. It casts a shadow of 16.60 meters here. Tim stands at a distance of 12.45 meters from the base of the flagpole. That's right here, 12.45, which is not as far away as 16.60. Such that the end of Tim's shadow meets the end of the flagpole shadow. This little weird thing is the end of both shadows. Tim's at 1.65 meters tall. I guess it's fairly tall. Determine and state the height of the flagpole to the nearest tenth of a meter. So we were given a bunch of information. We set up 2 different triangles. We do crisscross applesauce because they're proportional to each other. And then we find that 6.6 is the answer for X. For the next question, which is question number 37, I didn't do it on a separate page, it was right here. It says we're looking for a line that does not carry the square onto itself, carry the square onto itself, map onto itself. These things mean they're lines of symmetry which cut the square in half. Well, it looks like the purple line does just that. The green line does just that. The blue line does just that. But yes, when you graph this red line, that x equals 5, that does not cut the line in the square in half. So that's the one we're looking for. For question number 38, well, it gives us a line and it says it's transformed by dilation, but the dilation is centered at 3, 8. It's not centered at the origin. So the first thing I'm going to check is the center of dilation on the original line? If it is, which in this case it is, 8 equals 8 means that that point is on the line. That means the line doesn't move. If the center of dilation is on the line, That means you can make it bigger or smaller or whatever. A line is infinitely long anyway. It's not going to change position because normally it would go farther away from the center of dilation. But if it's on the center of dilation, it can't go anywhere. This is a emoji that I found. I understand it's like your head exploding because that is such an awesome piece of information. Question 39. To find the distance across a pond from point B to point C, well, it's got a bunch of different triangles, which means separate page. On a separate page, you're given information. You actually had this question on one of your problem sets already, but I'll walk you through it anyway. This is the small triangle. I have it in blue. This is the larger triangle. I have it in red. And you can see that they're proportional to each other, which means I can set up a proportion. 230 and 120 are in the first proportion. 315, which is the sum total of 230 and 85, divided by x, which is that shorter side of the triangle. Crisscross applesauce, and it's not too difficult to figure out what it is. Incidentally, if this is a 4-point question, you're trying to get all 4 points, which means you need to round correctly. It asks for the nearest yard, and you also need units. That would be yards, as I said. The next problem that we are going to go over is question 40. It tells us that M, R, and T are midpoints, which means they are directly in between the line segment. For example, from B to C, I know that's 10. The midpoint cuts the segment in half, so this distance is 5. This distance is 7 because a mid-segment is half the opposite side, because this opposite side is 14. And a midpoint cuts the segment in half, so if the whole segment is 18, this guy's 9. It asks for the perimeter of quadrilateral ACRM, so the way I set it up here is I know that ACRM is AC, CR, RM, and MA. It's all 4 sides. I traced it out on the diagram, and I also substituted them all in. That's 35. Oops, didn't circle the answer. Now I did. Moving on to the last page, which is the last 4 questions. Question 41, it tells us they are similar shapes, which means they have proportional sides. And there's a lot of different ways to answer this question. You could use the proportions to find this side, and then find the perimeter here, and then find the length of BC, and then use that in a proportion, but there's an easier way. The proportion of 2 sides of 2 similar triangles is equal to the proportion of their perimeters, which means the 30 over DEC, in other words, the perimeter of the big triangle over the perimeter of the little triangle, is equal to 12 over 5. Crisscross applesauce, and I get 12 and a half. The perimeter of DEC then is 12 and a half units. For question 42, please draw a picture every single time. It gives you a bunch of nonsense without giving you a diagram. Here's a triangle, and extended through point B means I'm drawing the line a little bit further until it reaches another extra point, an external point. I put the values on the diagram, and I can see that this is a classic exterior angle theorem question. Angle plus angle on the interior, the remote angles, is equal to the exterior angle. And, well, that's just algebra. For question 43, this took a little bit of doing, but an easy way to do this is to assign dots to the different corresponding sides. DE corresponds to EC, that's why they're both 1 dot. EB corresponds to EA, that's why they're both 3 dots, etc. And then what you can do is figure out which of the fractions is set up in such a way that it has the same things on the top and bottom, the same things on the top and bottom. 3 blue over 3 red is equal to 2 blue over 2 red. It seems like it works out just fine. The other ones, you can see that there's a little bit of mismatch. Here's blue on the top and red on the bottom, but that's not the same here. Here's 1 and 3, that's 3 and 1, that's not the same, right? So you should be able to figure that out pretty easily, which moves us to the last question, question 44. In question 44, it tells us that ABC is a dilation of scale factor K. ABC is dilated by scale factor K into ADE, so in other words, it got bigger. But anytime you are told that a dilation went down, a dilation preserves slope. So since the dilation preserves slope, that means that BC and DE are parallel to each other. As I said, in dilations, the slope is always the same. All right, this was the second video in a 2-part video series about the interim assessment number 3. Remember that the interim assessment is going to be 2 parts. You have the multiple choice and also the constructed response. Good luck studying.